Hi guys, so this is the part 2 of gRPC lecture series. In the first video, we discussed most of the theoretical concepts, the fundamentals concept of gRPC. You can go to my gRPC playlist and check it out that video. We discussed about all the fundamentals. We discussed about REST versus gRPC. We also discussed about why gRPC is faster than REST. We also discussed about how your HTTP works and your HTTP2 works. We also discussed about multiplexing, the concept of serialization, deserialization in terms of JSON and protocol buffers, and we also discussed about the concept of data encoding. So these are all fundamental concepts we discussed about the other video. Go and check it out first before moving into deep dive into this video. So in this video, majorly we will be discussing about the performance comparison between the gRPC based services and also your REST based services. Okay, so that's the architecture that I have created, and I have created the services accordingly. So I have created one order service, and this order service is kind of a consumer and the client for invoice services. So I have two different invoice services. One invoice services, this invoice services I have created based on gRPC, and this particular invoice service I have created in using REST. So the API, because the API here is a REST API, and I've created a server here, a service here, which is implemented as using the protocol buffers and gRPC concepts. And then here these two services are talking to this Postgres. So the agenda is same, the concept is same. Whether you'll do a RPC call or you call a REST API, these two things will always get you the list of invoices from the database, whatever in store here. So you have to pass the IDs, and then based on the IDs, it will get the data from the Postgres and send it to the order service. All right. So now we will have to, and now you see in the other video I explained you that if order service wants to call the gRPC service, it won't be creating a REST template, right? Because it's not a HTTP API. Think about it. It's not a HTTP API. It's a gRPC service. Okay, so you will have to do a remote procedural call. So so that's RPC. In order to perform the remote procedure call, you need to have a stub of your server. Okay, so for your server, so your server is this server. For this server, you need to have a stub, RPC stub, in order to call this guy. Okay, so this guy will get you the response. So if you see, the connections between here to here won't be multiple TCP connections. It will be multiplexed connection, right? A single TCP connection, and the connection between the order service and this invoice service in the REST API, there will be multiple TCP connections because of the fact it's a HTTP API. Okay, so I'll quickly show you. So this is my order service. Okay, now if you see, I have created these two APIs, right? So this is my REST invoice API. So this has I'll paste it here. Okay, so this has my REST. I'll paste it here. Okay, and then I have my gRPC invoice. I'll simply paste it here. Okay, and then here we will have Apache Beam. So this Apache Beam will be calling these two APIs. So this is your Apache, not Beam, sorry, benchmark, right? So it's a performance load testing tool. It will be calling these two separately, and then we will have a look at the numbers. Okay, so this is the overall architecture. So if you see, so this order service, right, it starts with the basic REST API. So this order service has the REST API which are being consumed by Apache benchmark. Now the inter-service communication between order service to your this invoice service, the gRPC based, is based on gRPC, right? It's not based on your REST. And then the communication between order service and your invoice service is based on Rust, not on gRPC. So I can also say that the communication between the order service and the invoice service is based on HTTP2, not on HTTP1. And I can also say that the communication between order service and the invoice service is HTTP1, not on HTTP2. Okay. So if you see, if you go back, first go back the invoice REST service. So we have did nothing. So it's a REST template, and we are creating IDs from 1 to 5 IDs. So in my database, so let me first open up my database. I already have my database here. It's running in a Docker container. I'll quickly start the database. Give me 1 second, guys. Alright guys, so my Docker is up, Docker desktop. So I'll start the database. Okay, so my database is also ready. So this is my database. I have this Northwind database, and then I'll reconnect it. And then if I have this invoices table, and I have already put in some kind of dummy data inside it. Okay, so I'll go and do view data. Give me 1 second. Data. Yeah, so you see I have these invoices, the invoice ID starting from 1 till 50. Okay, and that is the reason I have this 1 second. Okay, that is the reason I am creating 5 IDs, just that your any caching, even if there is any caching, right, which is not visible to us, because there are many layers of caching, God knows how many caches, right? So in order to caching doesn't work, I'm creating 5 random numbers in between 1 to 50, and then passing it as the ID in the REST template here. Okay, and I'm trying to get the data from the REST service. Which service it is calling? Invoice service is based on REST. We will come to that again. And if you go back to your invoice REST service, this is your service V1 invoices. This takes your invoices request body, and what is inside invoice request body. So it's kind of a post call, because it's taking a body. So it's not a get call. I'll simply say post call. Okay. And then I will again, go back here. Now it takes invoice ID. So, and then using invoices ID, it goes to the database and try fetching out all the IDs, convert it to a DTO object, and DTO object sends out this invoice ID and send it back to the order service. So I'll start this service. Okay. So now this is what this particular client is calling. So it will get you a list of invoices. How that invoices will look like, I'll open my Postman. I will show you quickly. Meanwhile, my Postman gets up. I have already opened it. We will talk about quickly to my another API. Yeah. Ignore the name invoice controller. I have copied it from my another service, right, just to make things faster. Now this is my gRPC invoice service. Now this service is calling to invoice service or different invoice service. If you go inside, now again I'm generating 5 random IDs and then creating a list of IDs. But you see, I'm not using a REST template. That's why I explained you in the diagram. I'm using a stub. How I generated the stub? Now that's the another important questions, because now after this video we discussed about the theory part, and then in this video we discuss about the comparison part. In the last video we'll implementing the whole gRPC application. The application I'll be showing you, we will be implementing that from very scratch, right? So we have buffers, right? If you go to invoices, I have these protocol buffers, right? If you see, I have this invoice proto, right? I have this invoice service proto. So this is where I'm defining my service. So your protocol buffers, your gRPC automatically comes with many plugins. Google has already exposed many plugins. Using those plugins in your particular IDE or not in your particular language, whatever you are using, framework, whatever you are using, you can generate the stub or RPC services call, etc., all those things. You see, I have created a protocol, a protobuf file, right, which is ID. And again, important thing, in the last video, if you remember, I said there are field names same as JSON, and then there are numbers assigned to it. Okay, now the serialization and deserialization and the data encoding happens based on this number, not on the field name. Field name is only for the developer's readability perspective. Internally, gRPC won't be using it. Remember, that's very important. Okay, that's how it's making the things faster, right? Apart from the HTTP, using the HTTP2. Now, when I'm saying repeated, that means these are scalar types. These are internal types of your protocol buffers. When I say repeated, means it's a list of invoice ID, list of a string, right? And which the name is invoice ID. And then if you see in the response, I have this invoice list, okay, which is also repeated. So you are sending a list of IDs, list of a string, and then you are getting a list of invoice type, right? If you go to invoice type, you will see this is another protobuf. When you do so, in your Spring Boot, you have many plugins. You go and you have to use, if you see, I'm using this proto.buff.id, and then if you see this is the protocol plugin. This is the source set. It will take the source from here and it will create all the implementations of protocols that we have defined, all the services inside those protocols we have defined, right? So protocol buffers are the fundamentals of it. So if you go to my build section, if you go to generated, go to source, go to my gRPC, you will see this is the implementation of your gRPC service that I have defined here. Alright. Now this implementation also comes with a stub. That's what we have used here. If you see, this is the stub. One second, you must be using some. Yeah, you see, invoice service stub. Okay. Now, and then here, if you go to Java, you will see what happened. You will see here that these are the implementations of all the protocol buffers I have defined. Right, customer name, created or updated, invoice ID, invoice number, etc., etc. All those things have been automatically created by my plugin. I have not created anything. I have only defined the definition of protocol buffer. Okay, so I'll go back, and then so this was the overview of order service, this service. Okay, and I also explained you this service. Now let's go to this interesting service, invoice service. Okay, so there are some red marks, right? But if you see, if I run this, it will run successfully, because these are some root source problems with the IntelliJ. That's the reason it's showing the red mark. But ignore the red lines, right? Focus on the fundamentals. So you see, same things are here, because I'm using the same proto definitions there, and I'm using the same proto definitions here, right? And when I'm starting it, if you see, as part of your startup, what it's doing, it's extracting the proto, generating the protos, right? So that's what it is doing. And then there are certain dependencies that I have used. You see, although there are red marks, it's very funny that my application has been started. So there is something wrong with the IntelliJ, right? If I start fixing it, I'll end up wasting some time. So let's not do that. So in the build.gradle, you will see. So these are the plugins I have used, and this plugin is converting my proto definitions to the actual implementations. And then here, this plugin I am using. If you can just you can Google search google.protobuffer, you will find all the details, right? And those are specific to Python and Go and C++. And then there are certain dependencies that I have added. So I have added this io.grpc protobuf and then stuff. And Spring Boot doesn't has any official dependency for gRPC, but there is some guy who has released one. So I'm using this Spring Boot starter for gRPC. Okay, and then there are some traditional dependencies in order to talk to database, etc., etc., all those things. Okay. So now if you see, these are entities talking to database, and if you go to my movie service IMPL, I don't know, maybe because I've copied it somewhere. So this movie services.impl we are extracting, because if you see in my gRPC, where is that? Yeah, if you go to build section and then go to generated gRPC, yeah, so there is something, this class. All right, so this class, they make it final, you cannot extend it. However, it creates this class that you need to extend, okay, and override the definitions. So it has invoice service IMPL base abstract class, and inside it has several methods. All right, so there is one method which is get invoices. If we'll go and search for get invoices, see this method. Okay, now we need to override this method. Okay, how can we do that? There must be multiple. This is step one. Yeah, this one. Yeah, right. This is because this is inside abstract. All right. Now we will just have to override this method. So the moment you will override and write the definition and put your application up, yeah, right, and you call this service, your RPC will your RPC stuff will be directly invoking this service. So there are no concept of controller and etc., etc., right? So those concept has gone away if you are using gRPC. It's not REST. You're using controller, one entry point, go to service, all those repository, etc., etc. If you will have to call directly service, your stuff will directly call the service. Okay, and then we'll doing the same thing. We'll taking up all the IDs and sending the data back. But when you are sending it back, you see it's a unary call. So in gRPC there are multiple calls. Okay, so in gRPC there are multiple calls. So let me write it down for you. It's a unary call. Okay, so there is by streaming, client is streaming, server is streaming. Okay, in order to just fulfill the client or server model, I'm using the unary call. See, I think this part I skipped explaining in the first lecture, the types of calls: bidirectional streaming, server streaming, and the unary call. This probably I'll cover when I'll deep dive into the gRPC framework, when we will be implementing this. Okay, so this will be a gRPC call, unary call. When I say unary call, that means client will send a single call to your server will fulfill that call, and then this whole communication happens using remote procedure RPC, right? So that's the RPC. And then what happens is, let's say if you have the server, you are using server streaming, your client will send one request, or server will keep on sending requests. Okay, your client streaming, client will send multiple requests, server will send one response. Bi-directional streaming is quite it's kind of messaging system, a ChatGPT kind of, like you can think, right? Not exactly it is. So client will keep on sending requests, server will keep on sending. So those things will happen one by one. Okay, so that's a unary call. Now I'll go back to my code here, and then the way you are sending the response back is on next and then on complete. You don't return or do all those things, because it's everything happens within a channel, right? There is a channel happens, right? We'll look at those things into the last lecture, which will be a bigger lecture, and the implementation part. Okay, so now you see we have the service and we have the client. So I'll go back to my Postman, and then from my Postman I have this where is invoice? Yeah, so this is my invoice REST API. Which API? REST API. Which API it is? This API I'm demoing currently. So this API, if I send back, if I do this, it will give you the response from database like this. Okay, Now let's call the gRPC. It's not the gRPC, it's the gRPC service, right? You see, it's a gRPC. So if I send this, you'll see, you'll get the data here. So it's a RPC call that we made, right? It's a RPC call. It's not call that we are making. Okay. So now let's go back and call our different APIs. So if I go back. Alright guys, so all my services are up. I have started my order service, alright, and then I have my invoice service. So this is the service which is based in gRPC. Okay, I'll clear this, and then I have my invoice REST service. This is also I have started. Okay, so now let's quickly go back to our diagram and test these APIs from Postman, not from Apache Benchmark. First from Postman, the basic flow in order to understand if everything is working properly or not. Okay, we already have seen these two from the Postman. Let's call these APIs from the order service. Okay, so if I go to order service, if I go to REST service and hit, you see I'm getting the response. Okay, because internally we were creating 5 IDs, if you remember, so it's a 5 response. Okay, so you see these are all random IDs. Okay, now alright guys, so we tested this API. So we called REST invoice API. This is auto service API. We see it's getting data. See, all these numbers are the random numbers, right? So if I go back and call this API, this is REST. If I call this API, these are random numbers and getting all the values. So this is REST. Again, this is REST, but internally the way it is calling your invoice service based on gRPC, internally those two services are talking via gRPC, not via HTTP, not via REST. However, HTTP, but not 1.0 using 2.0. Okay, and I'll go back and then go back to your architecture, and then I'll remove this, and yeah, okay, now I'll open quickly, and then so we tested these two as well. Now I'll go to my terminal and I'll start these Apache Benchmark in order to call these two APIs. Okay, alright guys, so this is my terminal I have opened, right, and I'll create another tab. So this tab I'll use for, okay, so I'll say AB, and the number of calls I'll set, let's say thousands. Okay, and the number of concurrent calls I want to send to my REST invoice REST API, I would say to order service, and order service eventually end up hitting concurrent 10 requests to invoice REST service. Okay, I'll say 100. Okay, and then which API it is? It is my HTTP localhost 8087, and then I'll copy the API name quickly. Okay, so I'll go and yeah, and then I'll hit. Now if you go and then you see this is my invoice REST service. It's getting multiple calls, received get invoice, received get invoice, received get invoice. All these logs are coming in. I'll go back. Okay, so completed 100 requests. Okay, so now it is done. Okay, so now I don't know why it shows failed request, because in the logs I see all calls are going through. Yeah, even here I'm getting all the 200 response codes, right? I don't know why it's sending the failed, but anyways, ignore that part. Okay, look at the part that I want to show you. So you see, around 50% of calls it has taken 2929 milliseconds, right? So if you convert 29 milliseconds, somewhere around 2.9 milliseconds, and then the time is keep on increasing, and the longest request around 100%, and the total time it has taken is this 7 seconds. So when they are creating a median, right, of everything, the overall performance is somewhere around 2929, which is your I would say 2 seconds, around 2.9 second, around 3 seconds, I would say, right? Somewhere around between 2.5 to 3 seconds. Let's not be very specific, because we don't rely on this AB numbers as well. Just assume, because it could be up and down, assume your 2.5 to 3 seconds, right, for your the time taken for a particular request. Okay, on an average. Okay, now let's go back and call another API. So I'll copy this. Okay, and then I will call another API, and then this is my gRPC invoice service. I would say gRPC. So even if you see, these numbers are going fast, right? So these numbers are going fast, and if you look at the numbers, right, if just look at these numbers, don't even look at these numbers, right, these numbers, just look at these numbers. So you see these numbers, 66, and then the longest it has taken 1495, which is 1.4 seconds, right? And this is 622 milliseconds, right, which is very less, the connection time, right? And here the connection time is 2929, right? So this is how this is the time per request, and then this is the time per request. So this is the connection time. I told you the wrong. This is the time per request. Mean, the total mean of average they have calculated is 2881.925 millisecond, which is somewhere around 2.8 seconds, right? Or you can consider 2.9, somewhere around 2.8 seconds. Here if you see, your time per request is 6.98.037 millisecond, the mean, right? So this mean is very less than this number, if you see, right? So this is which API? This is gRPC invoice API, which also conclude that this architecture, this flow, the first flow, this flow, right, this flow is faster than the REST API. Why? Because I told you the same concepts. If I summarize, one, gRPC uses HTTP2, which uses the concept of multiplexing, which also means that there were several HTTP call will be sent via one single TCP connection. Your service won't be using multiple TCP connections for each HTTP request. In the REST, this is not the case. In HTTP1, you use one TCP connection per request, and service has to maintain a connection pool. Second thing, if you look at the data format is the binary format in the upper flow, and the second flow, the data format is the JSON, which is text data format. So data encoding and the serialization deserialization become easier and faster in the first flow, not in the second flow, and then that is why it's kind of a late in the second flow. So in a nutshell, if you want to summarize, right, what is the best way, and again that depends from your organization to organization. The best way, if you want your application, your APIs to be high performant APIs, right? So I would recommend you to create your inter-services communication based on gRPC. However, let's assume that this is a second organization, and then you are, or let's say this is your some UI team. You want to expose your API. So you always expose your first point of your system, right, using REST, because that's easy to read, easy to implement, and easy to do many things, right? However, if you want faster communication among the services, I would recommend via gRPC. So your internal system should be using gRPC if you want high performance APIs, and in order to expose our APIs to cross organization, cross teams, you can use always REST because they are more readable, text based, and I would prefer REST if I'm talking to some other organization and sharing with some other cross team. And internally I can use gRPC. So that's the hybrid mode of we can use in the overall architecture. So that's how we conclude this lecture. The overall implementation of gRPC, when I say gRPC, that means this application implementation we will be covering in the separate next lecture, which will be a bigger one, right? That's the reason I have kept it differently. Okay, thank you guys.